Today I'm going to be talking about a barebones ESP8266 chip and a solution which has the chip built into it, like this Node MCU ESP8266. This chip here is the barebones one, and you can see that it actually is on this overall board right here. This is a plug and play solution. You can take this, plug it into USB, program it, stick it on a circuit board, route wires, and you'll have a solution that works. And for the most part, this is what I use. I have a use case where I'd like to run one of these off of battery power. And I found that this thing in a deep sleep mode, these chips have a deep sleep mode where pretty much everything turns off except like the real-time clock, so that it knows the time, so you can set things on a timer. So let's say every 3 minutes, come out of deep sleep, do something, put yourself back into deep sleep. While in deep sleep mode, these run in the hundreds of milliamps. So a lot of, it'd be hard to run this off a battery. These, however, runs in the order of microamps, a very small number of microamps, 9 or 10 microamps. So I wanted to build something around this. Now, it's a little harder to do projects with this because this is plug and play. It's got USB right in, but you have to build stuff around this in order to program it, flash it, and have it run what's programmed on there. So just a bit of research, read around the internet, looked at the data sheets and whatnot. I came up with these. Let's see if they actually show up on camera. They do. So this is the layout of the chip in each mode. So basically in programming mode and in normal operation. For some reason, normal operation is called flash mode. I thought flash mode meant when you flash it. No, that caused a lot of problems in the beginning because I was setting this up to be in programming mode when I was reading up flash mode, and because of my misunderstanding of what that meant, it was not doing what I wanted it to do. So basics. Of course, your VCC, that's got to be powered in both situations. 3.3 volts. This thing works on 3.3 volts plus or minus a bit. Don't give it 5 volts. You can't just plug in a straight USB into this and have it work without some sort of DC step down. So I actually have a little USB to UART, or I don't even know what that means. Maybe I'm saying it wrong, but it's this connector that takes a USB in and puts out 3.3 volts on one of these pins here, the third pin. So I'm powering it using this just for testing and programming. So VCC goes to 3.3. Chip enable, that has to be held high. And in programming mode, you've got to make sure that your transmit and your receive pins are connected to the receive and transmit pins on this device. This is the USB connector. So plug it into your computer. You can send, program. You can program your program onto this chip. So those have to be connected. You can leave 5 and 4 just regular inputs. Your GPIO 0. GPIO 15 need to be connected to ground through some sort of resistor. I'm using 10K resistors. Just because I found, like when I just Googled what a pull down resistor should be, there is some formula, but people just say use 10K, so I didn't bother reading up the formula. The GPIO 2 needs to be held high through a resistor as well, also using 10K, and then ground to ground. So when you power this thing on in this configuration, it will accept code coming in. So you take your Arduino IDE, you tell it you're programming to a generic ESP8266 board, you set your COM port, you hit flash, or I think it's flash, I don't know, I'll show it in the video anyway, and it'll load your code. And that's great. Once you're done, you unplug it, and then you've got to change it to this configuration. And when you take a look at this, you'll see that you still have your VCC and your EN chip enable held high. And your GPIO 0 and GPIO 2 go to high through a resistor. GPIO 15 still to ground, and of course ground to ground. That's basically, when you look at these two, the only difference here, of course, is your GPIO 0 was low in the programming mode. GPIO 0 is high in the normal mode. Now, I think, and I'm not sure because I haven't really played with it much beyond getting it running in my application, but I'm pretty sure that you can still use GPIO 0 and GPIO 2 as input pins, but they have to be held high in the setup. So when you first plug the thing in and it boots up, it will read the values here. And if they're high, then it go into normal mode. At that point, you can actually not use these as, or sort of start using these as input. So if you have some sort of sensor or anything in there, it'll just you can start using it as an input. I haven't done that. Some people online have had problems doing that, but you know what? For my application, again, temperature sensors around the house where I don't have easy access to a plug, you know, like my crawl space, things like that. Outside, I want to put one outside. This works fine. So what I did was I built a little jig, and I'm powering it through my bench lab supply, and here it is. So if I just sort of unplug some of these things here, and I'm going to zoom in. Let me get rid of these two, and I'll zoom in a bit so that we can take a look at it. Oops. Here a bit, and let's do a bit of focus. Are we focused? I think so. All right. So this thing is terrible. I mean, it is not. It's hard to follow. But essentially, what I did is I built a combination of these two papers that I was showing earlier. And since the only difference was how this GPIO 0 pin was held, I just have a little connector where I can swap out the pins. If I want to flash it, I'll put it in the red port, which the red's coming off. And then if I want to run it normally, I'll just put it in this port, and it's just everything's wired that way. So that's just to test that it works. Now, of course, I also wanted this thing to run in my implementation. And if I were to bring this back here, and let me actually, you know, I don't need to zoom out. This works well here. Because I want to show that's the programming one. Let's bring the running normally one. And you can see here GPIO 4. I'm using GPIO 4. It's connected to the DHT sensor, which is this fella here. And this reads not voltage. This reads temperature and humidity. Also, because I'm putting this thing into deep sleep and I want it to run every X minutes, I'm just for testing, I'm running it every minute now, but really I'll probably have it only run once an hour, once every half hour, something like that, because it's on battery. I want it to last a long time. You've got to connect your reset pin to your GPIO 16 pin, and there is something about GPIO 16 it's wake. It's called wake, and basically the only things that remain alive while this thing is in deep sleep is the real-time clock or the system clock. I don't remember right now. One of those two clocks. And it will essentially pulse the reset pin, bring it low, and then the chip will restart, and it'll do what it needs to do, and it'll run. So essentially, this thing will... I got to put it back in here. If I plug it in... If I plug this in here, and right now it's in operating mode because it's connected to the, let's see if we can actually see it here, to the non-red, let me zoom in, or not zoom in, focus a bit. It's connected to the port that's green and not colored red. It's in operation mode. And you can see here that I've bridged the reset pin and the GPIO 16 pin. Oh man, this thing is wobbling like crazy. There we are. And all the other pins are connected. In this one, I didn't actually set up my resistors. I have another one where I did, and that's right over here. And both of these work, honestly. I tend to use this one more because I can just move it around and program it like when I want to. It's easier than moving the chip in and out. In any case, I'm not running it with any sort of... for a long time on this, so this is more for testing. So when I run it off of my bench power supply, which I set to 3.5 volts, it basically when it starts up, connects to the Wi-Fi, connects to the MQTT server, and transmits, I suppose, it takes about 60, 70 milliamps, and then it drops down to 0. It's probably in the order of microamps. My bench power supply can't actually show that. So, pair it with, a couple of AA's running at 3 volts. This thing can run for a long time, or even pair it with one 18650 cell. I just worry about that. Well, actually, should be okay because you'll run it through some sort of DC step down, and it'll run okay. So that's pretty much it for today. I'm gonna add on some video here where I'm connecting into the computer and loading code, and I'm gonna show you the operation as well. Okay, so I just wanted to show what it looks like when you use the Arduino client to program this barebones ESP8266 chip. I showed this in the previous video with the Node MCU chip, the bigger board. It's very similar. There's not much of a difference. The basic change here is you're picking a generic ESP8266 module instead of the Node MCU 12E module. I actually have a 12F, but I don't think there's much of a difference. So, there's no 12F option here, so that's what I use. The only thing, when you pick a board from the board manager, it'll kind of fills in everything here for you, so you don't have to play around with this stuff. The only thing you got to pick is the port. So if you look at your computer in the device manager, you can see which COM port is available for you. You select that port and off you go. The major difference that I've done between this in the code between this one and the previous one is I'm now reading voltage, because I want to be able to tell when the battery's getting too low, and so I can go and replace it. So that's pretty much it. I'm just going to go ahead and upload this. It's going to compile anyway, and you'll see what this looks like. I don't remember if I showed this in the last video, but it really is not much of a difference. There you go, about 60% done there. And now it's done. Now, if you just had the regular Node MCU board, at this point it would reboot and just be working. But because this is on a circuit board and I had to set it up in the programming mode, I've got to unplug it, change things out, and plug in that GPIO 0, I think it was, to high instead of low, or GPIO 2, I don't remember which one it was right off the top of my head. And then we'll see this thing running. So what I'm going to do is I'm gonna stop the recording here, set it up, and then start up again. Okay, so I've set up my little jig here to work in normal mode. So right now the code is running. Well, once I plug it in, it will be. What I wanted to show you here was this little app called MQTT Lens. It's a Chrome plugin, and this is pretty much the only thing I use Chrome for these days. Is some apps that don't exist in Firefox. So what this does is it connects to my Home Assistant MQTT server and reads topics that come in. So right now I'm subscribed to the environmental sensor / crawl space, which is where this thing's going to be going. And I'm going to plug it in. And because I've set it up to wake up every 10 seconds, you'll see this thing start up every 10 seconds. Actually, what I should do is, and let me plug it in, and I'll bring up a PuTTY window too. So you'll see what this thing is working. So it's up right now. And let's go PuTTY, COM5, 115.200. Okay, so here we saw the first message go in. It's connected to the computer right now, obviously, otherwise you wouldn't be able to see PuTTY. Here it's starting up, connecting to the network, getting an IP address, sending the message, and here we go. You see the messages going in. 22 degrees, 5% humidity, which seems wrong, and 3.4% voltage, 3.47 volts voltage. And here we go again. So I've got this, I think it's every 10 seconds or so. So you'll see it start up and boot up and go every time. Next video, what I'm going to do is actually, now that I've got this this prototype built out, I'm going to design a circuit board. I've not decided if I'm going to use coin cell batteries or if I'm going to use like double A's or an 18650 to power this thing. I have lots of 18650, so I might use those. The difference is, though, I have quite a few DC step up converters here that I've already purchased. But I don't have any step down converters, so I can use the coin cell batteries and a couple of double A's because those will give out 3 volts. But the 18650 is 3.7 volts, so I'd need a step down to bring that down to 3.3 volts. Now this thing should probably run fine on 3.7, but I'm a bit concerned about it running on a fully charged 18650 cell, which is 4.2 volts, so I would probably still run it through a step down. So I just got to think about that a bit and see what makes sense. Double A's are, rechargeables are super easy to find. They're cheap. So I think I may end up doing that.